So in this question, we continue our discussions about the product moment correlation coefficient and the relation between that and the appropriateness of a linear model. So in question 163, we have 6 graphs and 6 correlation coefficients. And we're being asked to see which of those correlation coefficients is significant. We're using a 10% significance level and a one-tailed test. When you look in the tables, the product moment correlation coefficient critical values, you find that the critical value is 0.4716. So if you think of the product moment correlation coefficient being a number that can be anything from -1 to 1 with a 0 in the middle, then the critical values are 0.4716 and minus 0.4716. So anything in either this region or this region would be considered to be in the critical region, and therefore we would show a significant correlation. So any product moment correlation coefficient bigger than 0.4716 or less than minus 0.4716 would suggest significant correlation. So of the 6 correlation figures, 5 of them would be significant. So that's the answer to the first question here. Which of them are significant correlations? But the second question, the second part of the question is a little bit different. It's saying, of the graphs, now looking at the graphs, which would be ones that would be appropriate to look for a linear regression line, a straight line. So if we look at all of these 4 graphs, 5 graphs now that are remaining, the correlation coefficients there, all of the 5 significant ones, and if you look at the graphs, then clearly a linear model would look good. It would be a good model for this data, and for that data, and for that data as well. But if you look at graph E, we've got these 2 data points down here which show that trying to fit a linear model to that data, even though we've got a significant correlation coefficient, would not be appropriate. And similarly here, a quadratic model might work very nicely, but not a linear model. So there's the confirmation of the answer to part 2. In part 3, it's slightly different. It's saying if we look at graph B and we multiply all the x values by a half and add 0.1 to the y values, what will the product moment correlation coefficient of the new data be? And the answer is it will be exactly the same. It's not affected by linear coding. So these are both linear codings. We're not squaring the x values or doing 1 over the y values. We're simply multiplying or dividing, adding or subtracting a number. So the answer is that linear coding has no effect. So the product moment correlation coefficient is minus 0.8. There we are.